two examples of looking at factorising a three-term quadratic expression with multiple x squareds. First, check that there isn't a common factor running through the expression. 6, 19 and 10 don't have a common factor. From there, we multiply the 6 by the 10, so we multiply the number of x squareds by the constant on the end. 6 times 10 is equal to 60. And then we look for factors of 60 that add up to the number in front of the x, the middle term. So I want factors of 60 that add up to 19. Well, I could have plus 1 times plus 60. Everything's positive here, so there's no point trying any negatives. Plus 2 times plus 30. Plus 3 times plus 20. And I'm keeping my eye out what these add up to each time. 61, 32, 23. Could have plus 4 times plus 15. And that's the pair I want. Plus 4 and plus 15 add up to plus 19. So what I do now is I rewrite the expression, splitting the x's into two lots. So it's plus 4x plus 15x, and then I've got the plus 10. And now we look to factorise the front two terms, the 6x squared plus 4x. And the biggest common factor I can get there is 2x. We'll always be able to get an x, but this time I can get 2x. And I rebuild that expression. What do I multiply 2x by to get 6x squared? 3x. What do I multiply 2x by to get plus 4x? Plus 2. Now if this expression factorises, that will also be a factor at the back of the expression. And what do I multiply that bracket by to get plus 15x plus 10? Answer, plus 5. 5 times 3x is 15x, and 5 times plus 2 is plus 10. So now I've got a common factor that is the bracket, 3x plus 2. And how many lots of the bracket have I got? I've got 2x plus 5 of that bracket, and that gives me the factorisation that I'm looking for. Second example, this one involving negatives, which is more likely in an exam question. Again, check there's no common factor. 6 minus 7 minus 20, there's no common factor. So I now multiply the 6 by the minus 20. The number in front of the x squareds by the constant on the end. And that comes to minus 120. So I'm looking for factors of minus 120 that add up to minus 7. If two numbers multiply to give a negative, they must be of opposite sign. So I could have plus 1 times minus 120. And since I want them to add up to minus 7, it'll be the larger one that will turn out to be negative. So I could have plus 2 times minus 60. Plus 3 times minus 40. Plus 4 times minus 30. Again, checking none of these add up to minus 7. They're too far apart at the moment. I could have plus 5. How many times does 5 go into 120? That would be 2 5s is 10, carry the 2, 24. Minus 5 and 24. Still, that adds up to minus 19, not minus 7. I could have plus 6 and minus 20. 7 doesn't go into 120, but 8 does. Plus 8. 8 goes into 12. Once 4 left over, 8 goes into 45 times. So it's plus 8 and minus 15. Checking that one, that's the pair of factors that add to minus 7. So we rewrite this expression, splitting the minus 7x into two parts, plus 8x minus 15x, and you'll see that those two do equal minus 7x if you collect them together. Factorise the front end. I can get 2 as a factor and I can get x as a factor. Rebuild the expression at the front end. I need to multiply 2x by 3x, and I need to multiply 2x by plus 4 to get plus 8x. That should be a factor at the back if this expression factorises. What do I need to multiply that by to get minus 15x minus 20? Answer, minus 5. Minus 5 times 3x is minus 15x, minus 5 times plus 4 is minus 20. So my final answer, 3x plus 4 is a factor back and front. How many of them do I have? 2x minus 5 of them. And that completes the factorization.